This video is on Unit 5, Chapter 10, Introduction to Rational Functions, Lesson number 2, Adding and Subtracting Rational Expressions. So in your notes here for adding and subtracting rational expressions, we have some steps. Number 1 is to rewrite the problem using a common denominator. Secondly, we're going to combine the numerators and keep the common denominator. And then thirdly, we're going to simplify the remaining expression. So the key thing here is that when we are adding and subtracting fractions or these rational expressions, the denominators have to be the same and then they stay the same. So if the denominators are not alike, we have to figure out how to get a common denominator, change your fractions, and then add or subtract. So let's look at these first few examples. In example number 1, we've got just monomials here, and the denominators are already the same. So 13a divided by 4a squared plus 5a divided by 4a squared. So because the denominators are already the same, we're just going to add the top, keep the bottom. Add the top, keep the bottom. So 13a plus 5a is going to give me 18a, and we're going to keep that bottom, which is 4a squared. Then we need to make sure we always put our answer in simplest form. So we're going to simplify that fraction. 18 and 4 is going to reduce to a 9 and a 2. And then for your a's, you've got more a's in the denominator. So you got a squared in the bottom, whereas in the top you just have an a. So we're going to subtract those exponents. 2 minus 1 is 1, but it is going to be in the denominator. So there's your answer for number 1. Let's jump down to number 3. Y squared plus 8y over y squared minus 9 plus 2y plus 21 over y squared plus 9 or minus 9. Again, our denominators are already the same. So to add or subtract, again, you keep the denominator the same. You're going to combine the tops, keep the bottom. In the top, combining my like terms, I will have y squared plus 10y plus 21 over keep the bottom. Now what we want to do is we want to factor. To simplify this, we have to factor. So in the numerator, y squared plus 10y plus 21, two numbers that multiply to give us 21, that add to give you 10, is going to be 7 times 3. So the top is going to factor into y plus 7 and y plus 3. And the denominator is going to factor into y plus 3 and y minus 3. Now, just like we learned in lesson number 1, we can cancel common binomial factors as long as one's in a top and one's in a bottom. So my y plus 3's will cancel. And what I have left is y plus 7 over y minus 3. And again, that would be your final answer for number 3. I do want to show you a subtraction, so let's look at number 5. Again, we've got common denominators, n squared plus 3n minus 7 divided by n squared plus n minus 6 minus n plus 1 over n squared plus n minus 6. So we're just going to subtract our tops. Now, with the minus, I've always told you guys that we need to distribute that negative, and I would encourage you to do that again. So when you do that, when we distribute that negative, the n in the numerator becomes negative, and the 1 becomes negative. And what that does is that changes that now to a plus. So I just distributed that negative, and then that becomes a plus. So we're going to combine our numerators, n squared plus 2n minus 8 over, keep the denominator, and then we're going to factor. So in the numerator, I need two numbers that multiply to give me negative 8, that add to give me 2, which is going to be positive 4 times negative 2. So that's n plus 4 and an n minus 2. And in the denominator, I need two numbers that multiply to give me a -6, add to give me a 1. So 3 times -2. So I have an n plus 3 and an n minus 2. Now, again, we're going to be able to cancel our common binomial factors of n minus 2. And our final answer here is n plus 4 over n plus 3. All right, so those are examples of just common denominators already. So now what we need to do is we need to focus on ones that don't have a common denominator. Number 7, we've got 15 divided by 2x minus 16 divided by 3x. So when I look at this, immediately I notice that my denominators are different, and because I'm going to try to subtract, I can't do that. It's not doable right now until I get a common denominator. So we need to decide, what does my denominator need to be? What you're looking for here is a number that's big enough to divide by 2x and 3x and divide evenly. So when I look at 2 and 3, think of your common multiple, like the first common multiple that you would come to that they both divide into, well, that's going to be 6. And as far as the variable is concerned, x is big enough. They both just have 1x. So 6x is our common denominator here. And then from there, how does 2x become a 6x? Because what we have to do is we have to write the equivalent fraction now. So if we take 2x times 3, that gives you the 6x. So fractions, the way fractions work, whatever you multiply in the bottom, you're going to multiply by the same thing in the top, and you get a 45. So this new fraction is 45 over 6x. The second fraction, 3x times 2, gives us 6x. So multiply by the 2 in the top, and you get 32. And now we can subtract. 45 minus 32 gives me 13 over the 6x, and there's your answer. I would like to look at number 8 because it's another monomial question before I get to the binomials and trinomials. So I've got 4a divided by a squared minus 7 divided by 8a. So again, what we have to do first is come up with a common denominator. And remember, with the common denominator, it is your least common multiple. So a squared and 8a, least common multiple, is going to be 8. The variables are confusing at first, but a squared is going to be your common denominator because you don't want more than you need, and one of them has an a squared, so I need at least of a squared, and the other one has just an a. So a is going to divide into that evenly, so I'm good with just the a squared. So the first fraction, we would need to multiply by 8 in order to make that denominator 8a squared. So again, do the same thing in the top, and you get 32a. The second fraction would need to multiply by an a. So 7 times a is 7a. And now we can subtract our two fractions. 32a minus 7a is going to give you 25a. And we're dividing that by 8a squared. And then our last step here would be to reduce. A is going to divide into both the numerator and the denominator. So the a in the top is going to go away, and I'm going to have an a go away in the bottom. And I have 25 over 8a for my final answer on number 8. On the next page, we've got binomials and trinomials that we're going to have to try to get common factors for. So on number 9, we've got k squared plus 16 divided by 5k minus 10 minus 4 divided by k minus 2. So when we're looking at these, step number 1 said to rewrite the problem using a common denominator. I'm going to add to that. In step number 1, you might need to factor your denominators first. Factor the denominator first. That might be what you have to do in the very beginning in order to figure out what your common denominator needs to be. So only the denominators. Do not factor your numerators in this first step. Since the denominator on the first fraction has a common factor, so now I have a 5 times a k minus 2, and I'm comparing that to the other fraction that has a denominator k minus 2. So the common denominator is going to be 5 times k minus 2. Because again, we're looking for something that they both will divide into evenly. On that first fraction, the denominator is not changing, so the numerator is not changing. For the second fraction, we need to multiply by 5, so we're going to do the same thing in the top, and we get 20. So now that we've got common denominators, we can subtract. Remember that when you're doing this, that your denominator is not going to change. And we're going to take k squared plus 16, and we're going to subtract 20. You'll notice I haven't been distributing these last couple, and that's just because it's been a monomial on that second fraction, so I don't feel like I have to distribute that negative. So I'm going to take k squared minus 4. Now that I'm in the very last step, and your last step is always to simplify, now you can factor the numerator if you need to, which we do. The numerator is going to factor into k plus 2 and k minus 2 over the 5 times k minus 2. Your k minus 2's will cancel, and your final answer is k plus 2 over 5. Let's do another one. Number 10, 7 over y plus 8 plus 35 over y squared plus 11y plus 24. Again, when I look at this, my denominators are different. I know I've got to find a common denominator, but before I can do that, I need to factor the denominators. Y plus 8 is good. Your y squared plus 11y plus 24. Think two numbers that multiply to give you 24, add to give you 11. Multiply to give you 24, add to give you 11 is going to be a positive 8 and a positive 3. And you kind of have a hint because the first fraction has a y plus 8, and you're hoping that you have another y plus 8 in the second fraction. So looking at my two fractions, my common denominator, you make sure that you have everything represented. So I've got a y plus 8 in the first one, a y plus 8, and a y plus 3 in the second one. So I know I have to have a y plus 8, and I have to have a y plus 3. Now I don't need two y plus 8s because in each fraction there's only one. So I only need one. So my common denominator is y plus 8 and y plus 3. For my first fraction, in order to rename it, I'm going to have to multiply that denominator by the y plus 3. So we're going to do the same thing in the top, and I get 7y plus 21 plus the second fraction is not going to change. So now I can add my tops, keep my bottoms. 7y plus 21 plus 35 is going to give me 7y plus 56 over my y plus 8 and my y plus 3. Now the last step, again, is to simplify if you can. When I look at that numerator, the first thing that I think of is there's probably a GCF here, which there is. 7 divides evenly into both of those, so I'm going to factor out that 7 and get my y plus 8 over the y plus 8 and the y plus 3. Your y plus 8s will cancel, leaving you with 7 over y plus 3 for the solution there. Let's do another one. The more of these that you see, the easier this is going to get. So number 11, x squared minus 5 over x squared plus 5x plus 6 plus 1 over x plus 2. Again, step number 1 is factor the denominators if you need to find that common denominator. Because you're trying to get a common denominator. That's all that matters in that first step. What's in the numerator doesn't matter yet. So on that first fraction, it's going to factor into 2 times 3. Now when I compare the two denominators, I can easily see that my common denominator is x plus 2 and x plus 3. And the first fraction is not going to change. So it's going to stay x squared minus 5. The second fraction needs to multiply by the x, that's an x, plus 3. In both the top and the bottom. 1 times x plus 3 is just x plus 3. Now we can combine our tops and keep our bottoms. So x squared minus 5 plus x plus 3 is going to be x squared plus x minus 2. Notice how I went ahead and put that in standard form. Now we need to see if we can factor the top. Two numbers that multiply to give us negative 2, that add to give you a positive 1 is going to be x plus 2 and x minus 1 over my x plus 2 and my x plus 3, and your x plus 2's cancel. So your final answer, and I'm going to come over here to the side, is x minus 1 over x plus 3. Let's do number 12. So number 12, m squared plus 5m plus 6 divided by m squared minus 4 plus 2 over m minus 2. Again, common denominator comes first, so I only care about the denominator. A lot of students will try to factor that left numerator, but you don't do that. You don't factor that. The numerators don't matter in this first step. Only the denominators. I need a common one. So I'm going to factor the m squared minus 4 into m plus 2 and m minus 2. Now looking at the two denominators, I can see that my common denominator is going to be the m plus 2 and the m minus 2. And the first fraction, again, is not going to change. So I'm going to bring down that numerator. On the second fraction, I need to multiply by an m plus 2 in the denominator. So again, do the same thing in the numerator. And you get the 2m plus 4. We're going to add the numerators. Combining my like terms, I get m squared plus 7m plus 10 over m plus 2, m minus 2. Factor the top. Two numbers that multiply to give us 10, add to give you 7, will be a positive 5 and a positive 2. Keep your denominator. Cancel common binomial factors, and your final answer here is m plus 5 over m minus 2. I'd like to do a subtraction. So let's look at number 16. Number 16 has r over 2r plus 8 minus 8 over r squared plus 4r. So again, focus on the denominators. The left denominator is going to factor into 2 times r plus 4. There's a GCF there. And on the right, the GCF is r, and that leaves me with r plus 4. So there's several things here that we have to take into consideration when writing this common denominator. There is a 2, there's an r, and then they both have an r plus 4. So I need that in my common denominator as well. So my common denominator is 2 and an r plus 4. And then what we have to do is figure out, okay, so what do I need to multiply each fraction by to make that new denominator? So in that first fraction, the only thing that would be missing would be the r. So I'm going to multiply by an r in the bottom, which means I need to multiply by an r in the top, and I get r squared. For the second fraction, the only thing that's missing is the 2. So I'm going to multiply by 2 here. So I'm going to multiply by 2 here, and I get 8 times 2 is 16. Now with subtraction, again, you would if you had more than one term in that second fraction, I would say distribute. I don't feel like we need to distribute this because you can easily see that that numerator is r squared minus 16 over your 2r times r plus. If you need to distribute, go ahead and do that, but otherwise, just go ahead and subtract. Now we're going to factor that new numerator into r plus 4 and r minus 4. Keep the denominator, and we can cancel our r plus 4's, and my final answer is r minus 4 over 2r. That will be your final answer. All right, so those are your notes for Chapter 10, Lesson 2.